I did a problem. Zach, does that count?
Alright, so what we're going to do, and each one of these is we're going to isolate the absolute value or isolate what's being squared or what's being cubed before we do the inverse and solve. Alright, so in this case we're going to subtract 2 from both sides. So we get 3 times the absolute value of x minus 1 is less than or equal to 15. So we divide both sides by 3. And we get the absolute value of 2x minus 1 is less than or equal to 5. Okay. I did have a student that I noticed on their quiz. Some of you like little things to say to help you remember things. I don't know that I would call this a mnemonic, but when he was solving greater than or less than, he wrote greater because greater is or. And then he wrote less than.
Who did that?
At the top of his page, one of my students. So less than is and. Greater is greater or. Okay? So this is an and problem. So at this point we split it into 2x minus 1 is less than or equal to 5 and 2x minus 1 is greater than or equal to negative 5. So remember the second time we write the inequality, we switch the inequality and the sign. And then when we solve each of these individually, we'll add 1 to both sides and we get 2x is less than or equal to 6. So x is less than or equal to 3. And we'll add 1 to both sides and we get 2x is greater than or equal to negative 4. So x is greater than or equal to negative 2. Now, any and can and eventually should be written as a compound inequality. So, Zach, we would start with our least amount less than or equal to x less than or equal to our greatest amount. So any and can be written as a compound. Now, I was told this was not this weekend's ACT. Did anybody have a version of the ACT this weekend that did have a compound inequality on it? You could see them. You definitely could see them. Alright, so this is what the inequality looks like. And on the last quiz, a few of us knew how to answer it, but then didn't know which one was which. If it has inequalities in it, it's the inequality. Okay? And then we have the graph. So the graph of this one would come together, and comes together. So we would have a closed circle at negative 2, a closed circle at positive 3, and shade in between. There's the graph. And then finally, I ask you for the interval. And the interval for this one would be from negative 2 to 3. So, here are the 3 different ways we could have shown the answer for that absolute value inequality. Any questions about number 1? Cool. Alright, number 2, we divide by 5. And we get x minus 3 squared equals 5. Now what do? Take the square root. And when you take an even root, you always get a positive and negative. Now when we take an odd root, we do not. But when we take an even root, we get plus or minus. So now we the square and the square root cancel, so we're left with x minus 3 equals plus or minus root 5. So we move the 3 over and we get 3 plus or minus root 5. And those 2 solutions are our answers. Questions?
And it would always go in front.
Yes.
Okay.
Usually, normally it's the rational part plus or minus the irrational part, square root at the end. Okay, so on number 3, we subtract 1. And we get negative 2 times x cubed equals 54. We divide by negative 2. And we get x cubed equals negative 27. And we take the cubed root of both sides. Now an odd root is not plus or minus, it is either plus or minus. It's not both. Okay? And in this case we get negative 3. Because negative 3 times negative 3 times negative 3 is negative 27. Okay, all our different types of functions. Today and tomorrow we're going to solve the last two types of equations. We've already studied square root functions and we've already studied graphing cube root functions. So today we're going to look at solving square root functions and tomorrow, square root equations. And tomorrow we'll look at solving cube root equations. And that's pretty much it. Next 2 days review and your test is Friday. Okay? Now, the test. If you know what to do without having to sit there and stare at the problem for like 2 or 3 minutes before you get started, you're going to be just fine. So this week, that's what you need to make sure, that you can start a problem fairly quickly. So, like on last night's homework, when you look at this, you didn't have to memorize your moves. You pick numbers you can take the cubed root of. So the cubed root of a -8 is -2. The cubed root of -1 is -1. The cubed root of 1 is 1. The cubed root of 8 is 2. And you quickly begin graphing. So I don't think it's an issue of difficulty. I don't think anything we've done this unit has been terribly difficult. It'll just be getting them all straight in your brain between now and Friday. Okay? And like I said, the function tells us what to do. So go ahead and check 1 and 3, and then we'll look over and check 2 and 4. So take a minute, make sure you have good understanding that you're getting these problems right. And if you're not, let's make sure we ask those questions we need to ask in class, okay?
Because I had it and I put it right here, but then I tapped it, and then I think I can't make it somewhere. I don't know. Let's see, go. I think it's somewhere, but it's okay. So
So we would diagnose those on the test what we do.
I'm not even trying to mess up.
Okay, so in 1 and 3, hopefully we're squiggling the right way. So this entire, number 1, the entire function is increasing. So our increasing interval is from -infinity to positive infinity. But because number 3 has a negative out in front of the function, we have calls to reflection over the x-axis, which makes the entire function decreasing. So from -infinity to positive infinity. So this one's going up as we move. Number 1 is going up as we move from left to right, but number 2 is going down. Any questions on, that's not number 2, that's number 3. Any questions on 1 or 3? Cool. Let's check out the other 2. It is not. Thank you. If there's any type of shift to it at all, it's neither. And all of these had some type of shift. Okay, so the answer for the symmetry on number 2 was incorrect. Thank you. Any other questions? Okay, so hopefully you picked up your worksheet as you came in. Some of them I know I hole punched backwards. Go to the side that says notes. It may be the back side of your paper instead of the front. So go to the side that says notes. Alright guys, I'm going to start teaching now. If you feel the need to continue your personal discussions, Miss Fuller's room is open. You can go down there and we'll talk about discipline at the end of class. Y'all just get up and leave, okay? Miss Fuller's room, y'all know where that is, other side of the hall, kind of in the middle, so that those of us that want to learn have a really good opportunity to listen and ask questions. Okay? Alright, let's go ahead. We've already done these. So graphing these functions should be easy. These are just square roots. So when we think about our moves, we have to pick numbers that we take the square root of. So what would be the first one I would try? 1. The square root of 1 is?
1.
And what's the next number?
4.
4. And the square root of 4 is?
2.
And then
9.
9. The square root of 9 is? 3. Okay? Now, I want you to go ahead and graph these 3. Make sure you're on the correct side. I did hole punch some of them backwards. So let's see if you can graph these. If you need help, please ask.
These absolute values, right? James is on his game. What? Did you get a U?
No, it's the eye.
Oh, my eyes are not working. Whoa, watch your mouth. No, you actually, no, I'm actually wrong. And then this was
I think you were here. Who you were? What is it? We try that. I really like these.
Okay, so when we go and graph these, all we have to do is the shift. So this one gets shifted right 3 units. And then these are our normal moves. So if I go right 1, I go up 1. If I go right 4, I go up 2. If I go right 9, I am off the graph. And there's my function. Yes, sir.
Why don't you do the opposites like on the other one?
I did. The opposite of negative 3 is positive 3. Okay, on G, there's nothing under the radical of the x, so I do not shift left or right any. But the negative 4 takes the function down 4 units. So my endpoint, the starting position for this square root, would be down here at 0, negative 4. That's where the endpoint lies. Now, because of the 2 out in front, we're going to have to double these moves. So I go over 1 up 2. I go over 4 up 4. I go over 9 up 6. And then there's your graph. I totally missed it in a couple different places. Let's see if I can do that.
Sorry guys, less. Thanks.
Alright, a little better. Okay, the last one, the endpoint. My starting position for this one will be at -4, +3. But because it has a negative out in front, I'm going to take these normal moves for this parent function and I will go down.
Oh.
Because there's a negative out in front. So it's over 1 down 1, over 4 down 4,
So if there's
over 9 down 3. Yes?
negative on the inside, you go left.
Correct.
Down left.
If the negative is on the inside of the function, so if the negative were here, we would go left. But with a negative outside, that just tells us down. Good question. Alright, so,
Wait, didn't you go more than? No, but down. Shouldn't it be?
oh yeah, that should just be 2.
Like the 9 should be on.
That should be here.
For the Y.
And then, yes, thank you. That
Cause
should be here.
Cause I was like, wait.
I was doubling.
Okay.
Thank you.
And it continues, right?
Yes, it does. Good catch. Alright. So now we're going to look at how to use the graph to solve these, which is really the harder way. So then we're going to do it algebraically next. This asks f of x, solve each of the following. F of x equals 2. Well, that's asking us, what are the x values when the y value is 2? So if we come up here to this first function, and it's talking about f of x, that's why I picked the first one. What is the x value when that, so what is that x value? 7. Okay. This one, what is the x value for this function when the y is -2? So I'm going to come down here to -2, and I'm going to look for the x value. Let me line that up a little better. And what is the x value where it crosses right here? 1. Okay. And then finally this one is +2. What is the x value there? -3. Pretty simple. Alright, this one asks the same similar question, but this time it's an inequality. And this time we're looking at +1 instead of +2. So this is from this x value forward. So it is from 4 to infinity
Oh, greater than.
that it is greater than 1. Now I can't include the 4 because there's no equal to. Now on this one it asks where it is less than or equal to -2, which I already actually have drawn here, so I'm just going to change the color to deal with the inequalities. Where it is less than -2. So it is less than -2 from 0 to what is this x value? 1.
It would just be parentheses, wouldn't it? Because
Now
it's not
we
down
actually
here.
can include the endpoint, but we cannot include the 1 because this is not equal to, so we can't include the point that falls on that line, but you can include the endpoint. The endpoint does work.
Would it be alright to just do a parenthesis, or would it be wrong?
It would be wrong if it were a parenthesis.
I did not hear you. She definitely said.
Okay, and then finally, alright, so this one's not graphed far enough. And I won't give you one on a test that does this. If we came out here to 12, which, whoo, that's terrible. Right here. At the point 12, we would hit -1. And so this isn't a great one for this graph because our graph actually wasn't big enough. So if I gave you one on a test or quiz and asked you to solve it by graphing, enough information would fit on your graph to be able to solve it. So where is it less than or equal to -1? It's from 12 to infinity is where it falls below that.
And you got brackets because it's less than or equal to.
Correct. This time we do have the bracket with that number that falls on the line because of the equal to. Yes. Questions? All right. Okay, so if we consider this function without a graph, so now let's think in terms of there's no graph. The square root of x equals 5. What value of x has the square root of 5? What am I taking the square root of? 25. So what operation do we need to perform to each side of that equation to solve for x? How do we undo a square root?
Square it.
Square it. So we're going to square both sides.
Wait, where is it?
It's right below the ones you just did.
Oh, I'm out of it.
Okay, so we're going to do this one together, and then I want you to try these. These are all going to be you tries. Okay? So we're going to do this one together because this is very similar. All right, guys, I told you which room is available if you need to talk. Okay? So here we have 2 times the square root of x plus 4 plus 3 equals 15. So we have to get the radical part by itself. Okay? So to get the radical part by itself, the first thing you would do is subtract 3 from both sides. And you have 2 times the square root of x plus 4. And then we would divide by 2. So now we have the radical isolated. And that is our goal every time, to isolate the radical. Now we get here, we have to think, does this problem have a solution? Yeah. Square root of 36 is 6, so I'm good. So now I'm going to solve it by squaring both sides. X equals 32. And I can plug that back in and check it. If I plug in 32, this gives me 36. The square root of 36 is 6. 6 times 2 is 12. 12 plus 3 is 15. It works. Okay? So you try 1 through 5. Once again, I'll be walking the room, and I'm going to post the solutions in a minute. So if you're watching this video, open up the notes, and you'll see the solutions.
So number